students. Welcome to the another session on the limits chapter. So today we'll be discussing in this session. I'll be discussing the questions from worksheet. So let us look at the question number one. Limit extending to 2 x cube minus x square minus x minus 2 by 2x cube minus 3x square minus 3x plus 2. First of all, you need to go and substitute directly the value, and you have the problem only when it is coming 0 by 0. As long as it is not 0 by 0 form, there is no problem. So if I substitute 2 in the numerator, you will be getting 8 minus 4 minus 2 minus 2. Yes, 0 is coming in the denominator. Numerator, sorry, 0 is coming in the numerator, and 16 minus 12 minus 6 plus 2. Yes, you will be getting clearly 0 by 0 form in both the numerator as well as the denominator. So it is coming as 0 by 0 form. It is your choice to go for either expansion or L'Hospital rule. Expansion means you need to identify that where is that x minus 2 factor is coming out from both the numerator and the denominator. But instead of going for those tries, what I suggest you to go for the L'Hospital rule directly. So it will be 3x squared minus 2x minus 1 by 6x squared minus 6x minus 3. So now substitute x is equal to 2 here. 12 minus 4 minus 1 by here. 24 minus 12 minus 3, which is equal to 7 by 9. So very simple. Go for the L'Hospital. Okay. Next question is, if step x denote the greatest integer, f of 2x minus step of 2x, left limit is L1, right limit is L2. What is L1 plus L2? So here limit extending to 2 minus 2x minus x is less than 2, 2x is less than 4, whose step value will be equal to 3. So now here answer is 4 minus 3, answer is 1. And when you want to take limit extending to 2 plus this value 2x minus, because you have to give the priority this one. Step of 2x, x greater than 2, 2x is greater than 4, whose step value will be 4, is equal to 0. So L1 is equal to 1, L2 is equal to 0. So the L1 plus L2 is equals to A. And actually this is simply 2x minus step of 2x. This is fractional part of 2x also. So the graph of fractional part of 2x will be 0 to 1 by 2, 1 by 2 to 1, 1 to 3 by 2, like this will be there. So for this one, right limit is always 0, left limit is always 1. Limit extending to 2. So clearly 8 minus. So this is 0 by 0 form is there. Cos of 2 by something. So this is a finite value. This value always lies between minus 1 to 1. I just don't know the value. But at x is equal to, this value will be equal to x minus 2 whole square. X minus 2 whole square. Okay, x minus 2 whole square. So this value is going to be 0 into something. Value will be 0. So finally, you will be getting here limit extending to 2. This value goes to 0. You have this one as x minus 2 into x plus 2 by this value will be equals to x minus 2 into x cube is there. So x square plus 2. Actually, minus 2x square is there. So plus 2x you write. So x minus 2 cancel. X is equal to 2. This value will be equals to 4 by, okay, this value will be 4 plus 4, 8 plus 2, 10. So the answer is equal to 2 by 5. Okay. Look at this question. Limit extending to 0, tan square x, tan square of this one. So it is coming as 0 by 0 form. So what I'll do is, going for the L hospital is a very lengthy calculation. Instead of that, I will go ahead with using this formula, limit extending to 0, tan x by x form is equal to 1. What I'll do is, as extending to 0, this value is going to pi, but not, but not 0. So what I will do is, limit extending to 0, tan square, pi minus pi secant power 4x by, I will write the same thing here. So square is there, pi square of 1 minus secant power x whole square, and here pi square into 1 minus secant power x whole square by pi square x power 4. This cancel. This value goes to 1. Now you need to look at this portion. So this is limit extending to 0. 1 minus secant square x whole square into 1 plus secant square x whole square by x power 4. Look at this value as extending to 0. This value will be equal to 4, and this value will be, okay, 1 minus secant square x. So you are going to get cos square x minus 1 by cos square x into x square whole square. So as extending to 0, this is sin square x by 1. So this entire thing is 1. So final answer is 4 for this question.
So limit extending to 0, extending to 1, this value we need to write. Okay. So what is the value? Clearly denominator is in the form of 0. And numerator also f of g of h of 1, 0 by 0 form. So it is better go for the L hospital rule. So here what I'll do is, okay, I'll be going for what is the f dash of, f of g of x, f of g of h of x. It is sine of cos of x, whose derivative will be equal to cos of x square into cos is minus sine of x square into x square is 2x. So it is simply at x is equal to 1, we need to write 2 minus sine 1 cos of cos 1. So the answer is going to be B. B is the right answer for this question. Limit extending to 0, x cube by x cube into this one. So when such type of thing is there, you need to rationalize one way. Okay. Or you can also do y is equal to 1 by x. So what is happening? This question will be limit y tending to 0, x cube will come in the denominator as y cube square root of 1 by y square plus square root of 1 by y power 4 plus 1 minus square root of 2 by y. So this is limit y tending to 0 y cube. Here y square, y power 4 comes out y square. So LCM is y square. Y will be coming out. So you'll have one more y here. So root over 1 plus root over 1 plus y power 4 minus root 2. One way is you can go for the El hospital here, means differentiation. So denominator is y power 4. So you are going to get y cube, and derivative of this one is 1 by 2 root over 1 plus root over 1 plus y power 4 into derivative of this one is 1 by 2 root over 1 plus y power 4. Derivative of y power 4 is 4y cube. This cancel. Now you substitute y tending to 0. So this value 2 into 2, 4, and inside value is root 2. So answer is going to be 1 by 4 root 2. Answer is 1 by 4 root 2. Limit extending to 0, 2 to the power of x, etc. So here what I will do is 2 power x whole square minus 2 into 2 power x plus 1 plus 1 minus cos 2x. So I will write here x square here. I will write here x square. So this value will be equal to 2 power x minus 1 by x whole square, and this is 1 minus cos 2x. So 1 minus cos 2x, happily you can take it as, okay, 2 sin square x square. 2 sin square x by x square. So this value is equal to 1, and this value is equal to log 2. So answer will be log 2 whole square plus 2, because you are using the property a power x minus 1 by x. Okay. Limit extending to minus infinity. This one. So limit extending to minus infinity. Anyway, mod x is there. And here answer is numerator is third degree, denominator is also third degree. So when the coefficients degrees are same, the leading coefficient is going to be the answer. And the answer is equal to minus 3 by 5. Nothing, you need not look at anything here. But extending to minus infinity, no problem. We are giving the only mod x point only. So the answer is minus 3 by 5. Limit extending to 0, sin 2 sin x minus sin 2x by x cube. Here there are the two ways of doing. One is expansion, one is the factorization, and the third one is El Hospital rule. So I will go ahead with, okay, I'll be going ahead with factorization. 2 sin x minus 2 sin x cos x by x cube. When I'm writing this one, 2 sine x. Actually, every time you are supposed to write limit extending to 0. But in the object to exam, better avoid the right. Here, what happened? 1 minus cos x. So you keep 1x here, 1x square here. So this value is equal to 1 by 2. This value is 1. So the final answer is 1. Okay? The final answer is 1. Limit extending to 0, x tan 4x minus 2x tan 2x by 1 minus cos 4x whole square. Here again, L'Hospital is applicable, but I'm not going with the L'Hospital rule. So what I am going to do is x tan 4x is there and a 2x tan thing is there. So if I take x common, tan 4x minus 2 tan 2x. So if I go ahead with this one, my intention is this one, 1 minus cos 4x. For example, if I write x square whole square, so this will be reduced into the standard form. So I need to write here x power 4. So x cube will be there. So how we can go about this one? So in that case, what I'll do is this tan 4x can be written as 2 tan 2x by 1 minus tan square 2x. You can go ahead with this approach. Okay. Otherwise, also, maybe you can try further a hospital rule that is going to be that is going to be tan 4x plus x into 4 into secant for 4x minus 2 tan 2x minus 2x into secant square 2x. Derivative of 2 is 4. Okay, by 2 times of 1 minus cos 4x into derivative of minus 4 cos x is 4 sin 4x. Okay, so now let me write here 4x. I'm multiplying with 4. So here x, here 2x into 4, here x. I'm dividing with this and here x. So this value will be equal to 4. This x will be cancelled. This value will be equal to 4. X cancel. This is plus 4. This value is equal to 1. And extending to, but here this value goes to 0. So they automatically this is going to be 0 by 0 form. This is going to be 0 by 0 form. Okay, so further this is one approach. And one more thing is what you can do is go for the normal trigonometry. In the normal trigonometry, what I'll do is I will write x common. This is sine 4x by cos 4x minus 2 times of sine 2x by cos 2x by 1 minus cos is 2 sine square 2x whole square. So it is x common sine 4x cos 2x minus, okay, I will take 2 sine 2x cos 4x by, actually as extending to 0, this is value 1. So you need not worry. 4 sine power 4 into 2x. Actually, 1x, one sign will be eliminated. Okay, if you write 1, 2x, etc. And here, sin A cos B minus cos A sin B, if I take only one part, so it will be equal to x into, this value will be equal to sin A cos B sin 3x minus, you will get sin 2x into cos 4x by 4 sin 2x sin cube 2x sin cube 2x. So this value is equal to 1 by 2. This value is equal to 1 by 2. Now you need to solve this portion and you will be getting the answer as 1 by 4. You will be getting the answer as 1. Next question, if f is defined from R to R be an increasing function such that f of x greater than 0, limit extending to infinity. So here what happened, as extending to infinity, function is always increasing, going up to infinity. So as per this one, I can say f of 9x is approximately equal to f of 3x. So when as extending to infinity, 9x is almost equal to 6x almost equal to 3x. So if this value is same in between this one also. So generally what happened? F of 3x less than f of 6x less than f of 9x, because the function is increasing. Function is increasing. So divide with f of 3x. This value limit 1, f of 3x they mention. Here f of 3x by default 1 is there. So f of 3x by using the sandwich theorem, this value is also equal to 1. Next question, extending to infinity. Extending to infinity. So the base is equal to 2. Base is equal to 2. And the numerator is, again this is also separately, so numerator, sorry, exponential is 3 by 2. So this answer is 2 to the power of 3 by 2. So the answer is 2. This is directly 2 to the power of 3 by 2. So your answer is B. Extending to infinity, so this value is equal to 1. So this is of the form 1 to the power of infinity. 1 to the power of infinity simply e to the power of limit extending to, here infinity is there, x square plus x plus 3 by x square minus x plus 2 minus 1 into x. So e to the power of limit extending to infinity, x square cancel, x minus of minus x, 2x, 3 minus 1 plus 1 into x by x square minus x plus 2. So extending to infinity, numerator is second degree, denominator is second degree. So leading ratio of the highest coefficients will be 2. So the answer is e square. If limit n tending to infinity x power n exists and finite, x1 is equal to 2, xn plus 1 is equal to this, what is the limit n tending? So when n tending to infinity, x power n plus 1 is almost equivalent to xn. So here you will be getting xn is equal to a plus b xn by b plus c xn. So bxn plus cxn whole square is equal to a plus bxn. This cancel. So the answer is equal to a by c. So as n tending to infinity, xn plus 1 is equal to xn. This is very important one. Limit extending to 0, x square log cos x by log of 1 plus cos x. clearly it is 0 by 0 form. It is clearly 0 by 0 form. So what you can go? Do you want to go for expansion or L hospital? Whatever. So I would suggest you go for the L hospital rule. So the numerator is 2x into log of cos x plus x square into derivative of log of cos x is minus tan x. Yes, because derivative of cos log cos x is 1 by cos x minus. So it is minus tan x. But again, it is not moving away from 0 by 0 form. That is a problem. By 1 by 1 plus x square into derivative of this one is 2x. So x is cancelled. So this is 1 plus x square by 2 into 2 log of cos x plus minus x tan x. But here now you apply the limit, it is not 0 by 0 form. It's only 0 by something. So the answer has to be 0. The answer has to be 0. Very simple, you can say log of 1 plus x expansion, you can take x square will be cancelled. So this one will be there. So answer is equal to 0. A greater than 0, B greater than 0, limit n tending to infinity. What is this one? So n tending to infinity, b power 0 is 1. So a 1 to the power of infinity. When it is 1 to the power of infinity, answer is e to the power of limit n tending to infinity, or I will say m tending to 0, where I am writing n is equal to 1 by m. So a plus b power m minus 1 by a minus 1 into, instead of n is 1 by m. So e to the power of limit m tending to 0, this is b power m minus 1 by m into 1 by a. I am rewriting. So what is this one? This value is log b. So answer is e to the power of log of b to the power of 1 by a. So answer is b to the power of 1 by a. Why? You should know e to the power of log x base e is equal to x. Are here any value here same, then value is going to be x. Next question is limit n tending to infinity a plus e power nx by x plus a e power nx. So what is this value? Okay, so here x is greater than 0, e power nx goes to infinity, e power minus x goes to 0. X is less than 0, e power nx goes to 0. So if x is less than 0, this value is a plus 0 by x plus a into 0. So answer will be equal to a by x if x is less than 0. So whenever this property, because e is the value greater than 1, so this is the condition we have to apply. L and m are the roots of the equation ax square plus bx plus c is equal to 0. Then limit extending to alpha, what is this? See, let us assume a is greater than 0. If I take a as greater than 0, ax square plus bx plus c curve will be like this. These are the roots L and M. If alpha is any value between L and M, ax square plus bx plus c will be negative. So the answer is equals to minus 1. Answer will be equals to minus 1. Okay. And if alpha is here or here, in that case, always answer is going to be 1. So irrespective of alpha. So here A is greater than 0, A is greater than 0, alpha belongs to L comma M, answer is minus 1. And if A is less than 0 also, the curve is going to be like this. They are having the opposite sign. Okay, because modulus of this one is we need to make it as positive, and this is negative and this is positive. So clearly, if alpha lies between element, the answer should be minus a by mod a by a. If alpha is does not belongs to L comma M, irrespective of a, this value is always equal to 1. Okay, so the answer is C. Next question is, f is defined from r plus to r plus, positive real numbers to positive real numbers, and f of x minus x is equal lambda, and satisfying this condition. So you have to find what is f of f, this one. So this value is f of x is equal to x plus lambda. So it is x f of y plus lambda is equal to xy plus lambda plus x. Lambda x is also x. So f of y is equal to y plus 1. So what is our f of x? F of x is equal to x plus 1. So the question is, limit extending to 0, 1 plus x whole to the power of 1 by 3 minus 1 by 1 plus x power 1 by 2 minus 1. Just go for the L'Hospital rule. 1 by 3 into 1 plus x power minus 2 by 3 by 1 by 2 into 1 plus x power minus 1 by 2. So the answer is going to be 2 by 3. Next question, limit n tending to infinity x power n into log x is equal to 0. So n tending to infinity. N tending to infinity means log x base e is going to be infinity. Is equal to 0 is there. So this value has to be 0. So x to the power of n tending to 0 as n tending to infinity means x is less than 1. X is lies between 0 and 1. If x is lying between 0 and 1, log a base b, this will be negative if this is greater than 1 and this is less than 1, or vice versa. So therefore, this value has to be negative. This value has to be negative. I think this should be n tending to infinity. Okay. So limit n tending to infinity, what is this? Numerator is the third degree polynomial. Denominator is also third degree polynomial. So the highest coefficient here, n cube is 1, and denominator also n cube is there. Okay. N cube in the numerator, n cube is there. In answer should be equal to, okay, what is the n cube coefficient? N cube coefficient is 1 only. Okay. Yes. I'm repeating this question. So here it is, limit, I think it should be m beta. There is a printing error. Otherwise, extending to infinity, you cannot do this one. So limit n tending to infinity, okay, answer is n square, n plus 1 whole square, n square. So n cube plus 2n square plus n 5. Denominator is n cube plus 2n square plus 3n square, 5n square plus 6n minus n plus 5n minus 2. So this value has to be 1. So no answer is possible here. There is no answer. And here case number 1 is n should be equal to 0. So answer should be equal to 1. The answer should be equal to 1. So there is a some printing error or some adjustment error was must be there. So n tending to infinity, numerator is cubic degree polynomial and the cubic polynomial denominator also cubic polynomial and leading coefficients are 1 comma 1 only. This question is limit extending to 0. I will write it as a power x minus 1 by x into x by sine x. I will not think too much about this one. I'll just go. Or you can go for the L'Hospital also. What is this value? This value is log A. This value is equal to 1. So answer is log A. Next question. Limit n tending to infinity n factorial by this one. Interesting question. So what is the numerator? Numerator is n factorial. Denominator is if I take n factorial out, because you can write it as n plus 1 factorial as n plus 1 into n factorial. So this is n factorial into n plus 1 minus 1. 1 cancel. This is cancel. 1 by n. So the answer is going to be 0. Answer is going to be 0. A is greater than 0, n is any real number. Limit extending to a x power n is simply a to the power of n. There is no second thought about that because it is not going for any 0 format. So 0 by 0 format is not there. Straight away we will write a power n. Limit n tending to infinity, again the same way we discussed little earlier. Okay, so what is this one? X is less than 0. Okay, n tending to infinity, so this value going to be e to the power of minus infinity. So this value and this value goes to 0. So left out value is, okay, just so here what is the thing is n tending to infinity. So n tending to infinity means in the mention x is less than 0. So nx tending to, this is negative, so it is minus infinity. E power nx goes to e power minus infinity goes to 0. So if someone says limit n tending to infinity, this value will be equal to sin x as it is minus 0 by 1 plus a into 0. So the answer is sin x. But in case if I mention x is greater than 0, if x is greater than 0, nx goes to infinity, e power nx goes to infinity, e power minus x goes to 0. In that case, I will write e power minus nx into sin x minus 1 by e power minus nx plus a, in that case minus 1 by a. So here, what is minus 1 by a? If this is x is greater than 0, and this value when x is less than 0. So they have given only minus 1 by a. I think it should be x should be greater than 0. It should be greater than 0. Okay? Right. So you take these two options. This was already discussed earlier in very similar. Okay. So here what happened? Here x square as given tan 2x to tan x. So what is this one is x square into tan 2x. You can write it as 2 tan x by 1 minus tan square x minus 2 tan x whole square by 1 minus cos 2x is 2 sin square x whole to the power of 4. I'll tell you, as x is very small, I can write x is equal to tan x is equal to sin x. If I apply that way, this will be x square. Now 2 tan x common I can take. Outside will be 4 tan square x. So I will be writing x square. Into this is 1 minus 1 minus x square, because I'm writing this one 1 1. So it is x power 4 by this is 1 minus x square into 2 to the power of 4 x power 8. Okay, I'm writing this value. So x power 8 value will be cancelled out. So now x is equal to 0. 4 by 16. So the answer is equal to 1 by 4. So here simply you need to write tan 2x as 2 tan x by 1 minus tan square x. Extending to infinity, this value you look at. So if you take this one, it is infinity and this is infinity. So you need to together you need to take what is this denominator is going to be x square plus 1. Numerator is x cube plus 1 minus x square plus 1 into alpha x plus beta. This is exist and equal to 2 they are saying, where limit extending to. So denominator is second degree. So numerator should be second degree, but here x cube here. So clearly alpha is equal to 1. If alpha is equal to 1, here x cube will be cancelled. Now next coefficient is x square coefficient. Nothing is there. Here x square is the beta. So minus beta is equal to 2. So the answer is 1 comma minus 2. If step x denote the greatest integer less than or equal to x, what is this value is equal to? So here you need to go ahead with this one. Step of n square x is always less than n square x or here n square x minus 1. So when you apply this one, step of n square x, this value will be n into n plus 1 into 2n plus 1 by 6x. And this is also less than n into n plus 1 into 2n plus 1 by 6x minus adding this one is n times. By n cube you are doing, by n cube you are doing, by n cube you are doing. So as per the sandwich theorem, the leading coefficient here, this value is going to be 1 by 3. So the answer is x by 3. The answer is x by 3. Okay. Just simply you remember sigma n square by n cube is equal to 1 by 3, where limit n tending to infinity. Sigma n cube by n power 4 is equal to 1 by 4. Sigma n power r by n to the power of r plus 1 is equal to 1 by r plus 1. That's you need to do. What is this answer? You look at expansion or factorization, what you do, I will write this one as 2 power x minus 1, 3 power x minus 1. I will write 1x here, 1x here. So this is a log 2, this is a log 3. Log 2 into log 3 will be the answer for this question. So with this one, I'm concluding this.